Hi guys, hope you all doing well. So here in this video, we are going to analyze an important question on stereochemistry. We know that the stereochemistry is the most important topic in organic part of many chemistry related examinations. Why? Because if one have a strong command on a stereochemistry, one can solve most of the questions from organic section because the organic section, that means the questions on organic section will relate with stereochemistry in many parts. That's why it is very important to have a command on a stereochemistry and its basics and advanced concepts. Okay, so here the question relates with the conversions from, just look at the given question here. So we have given with sawhorse projections and also Newman projections. So we need to convert sawhorse projections to Newman projections and Newman projections to Fisher projections and Fisher projections to wedge projections. Like that, so we need to have a command on these conversions of the given isomers or conformations. Okay, so if you have a strong command on conversion of these projections, then we can solve these kind of questions in many chemistry examinations. So watch the video completely to get the concept, and you are going to get the justification of answer for this question. Okay, and if you are not subscribed to our channel yet, just do subscribe for more updates. And if you like this video, just click on like. And if you are further interested, you can visit and join the website chemmasters.online, and where you can get the best concept oriented online courses, and where you can also practice very high standard online test series and mock tests to boost your success rate with minimal prices or fees. Okay, right, now just look at the question. Choose the correct answer from the given statements about second, third, fourth and fifth with respect to 1. So just look at 1 here. We have given with sawhorse projection. I'm going to convert that sawhorse projection into its Fisher projection. Now just consider this is the vertical line, and I'm considering methyl group on the bottom of the vertical line. In that case, chlorine is the top of it. Okay, now so when you look at this sawhorse projection from here, so these two hydrogens are right side to us. Okay, and these two hydroxy groups are left side to us. So just listen carefully and draw. If you have a pen and papers, just draw along with me. Okay, right, and this is the one. Now just try to draw the second sawhorse projection in the same way, but here in first and second we have given with eclipsed sawhorse projections of the molecule, right? So whenever we have given with eclipsed projections, we need to just take the eclipsed forms, that means the groups, the largest groups on the vertical line. Okay, so here just take chlorine, and here is the methyl group. Now OH and hydrogens on the right side. Okay, now here is the hydrogen and here is the OH. Now you can see that the third one is given as a staggered conformation. So we need to convert this staggered conformation into its eclipsed conformation to convert this sawhorse form into what we say Fisher projection. Okay, now I'm just doing that. The bottom carbon is rotating in through the 180 degrees. Okay, so just do the same thing. That means, so this part is not changing, CH3 H, and here is a OH. Now I'm just doing this only, okay, rotating the backside carbon. Now the chlorine is here. Now whenever the chlorine comes here, then hydrogen here and OH will move here. Okay, right, now so this is the eclipsed conformation. Now we can convert this sawhorse eclipsed form into Fisher projection. So here is a chlorine, and here is a methyl group, and here is a hydrogen, here is a OH. Now just do the same thing as we done for the first two. Fisher projection conversions. Okay, here is a OH. Now you can see here the fourth one is given as a Newman projection. Okay, now I'm just converting that Newman projection into sawhorse conformation. So this is the front side carbon. Okay, just consider. Now on the front side carbon, one methyl group is like this, and so we are looking from the front side carbon from here only. Okay, so in this case just hydrogen is right side to us, so these two groups are right side to us. Okay, so here is the OH. Now so the chlorine, sorry, just wait. So this OH. Now just complete the first one and don't get the confusion. Here is the OH. Now just go to the backside carbon. On the backside carbon, chlorine is the just bottom end. Okay, so just do it, just write now the OH here and then hydrogen here. Okay, now just do the same thing for the fifth one. Here on the first carbon we have methyl group here and hydrogen. So here is the OH. Now the bottom group is chlorine here. Now here is the hydrogen and here is the OH. So these are the these are the sawhorse projections of the given Newman projections. Okay, I'm just converting them into wedge forms. Okay, now in the wedge form you can draw, so the methyl and chlorine. Okay, so this is the longest chain. Now on this we are just looking from here, right, from this carbon end. Now in that case the hydrogen is right side to us, so we are making it with a thick line. Now then OH group is backside end. Okay, now just here the chlorine is on the what we say, on the plane. Now this OH is right side to us. Now just do with a thick line, or rather with the thick line. Now here is the hydrogen. So just do the same thing on this. Here we have CH3, now chlorine. So here is the hydrogen with thick line and here is the hydroxy group with dotted lines. Now here is the hydrogen with thick line and here OH with dotted lines. So after converting them, now try to assign the RS notations, because RS notation will give you the best relationships. Okay, there if you have the command on RS notations or RS nomenclature, then it is easy to relate the different conformations, or the enantiomers or the diastereomers or the identical. Okay, you can easily find out. Now just try to check out the first one on this chiral carbon. I'm going to label the carbons here 1 and 2 and this is a 3. Okay, on first chiral carbon I'm going to give the notation, RS notation. So first priority for chlorine, second priority for hydroxy group and third priority for this branch. So the rotation is anti-clockwise with least priority hydrogen on the horizontal line. So whenever the least priority atom or group on the horizontal line of the Fisher projection, we need to take the opposite notation for the direction or priority order. So priority order is anti-clockwise direction with the least priority hydrogen on the horizontal line. So we need to take opposite notation for it. So we can take R for it. Okay, so 1R. Now for the second, here the first priority for hydroxy group, second priority for this branch and third priority for methyl group. Okay, so what is the direction here? The direction is clockwise rotation with least priority hydrogen on the horizontal line. So it must be yes. Okay, so we can give 1 or 2s for the first sawhorse projection. Okay, right, now just look at the second one. On the second one, so here you can see, so first priority on this chlorine, second priority here, third priority here, and it is anti-clockwise direction with least priority for that hydrogen on which is on the horizontal line. So we can take R here. Okay, now for the second one, 1, 2 and 3 and 4. So it is also anti-clockwise direction with least priority hydrogen on the horizontal line, and we can give R for it. You can see on the first compound it is R S, on the second compound it is R and R. We know that RS and RR, or we can say what we say RS or Yes, yes. Whatever in these two conformations are simply diastereomeric in nature. They are diastereomers. They are not going to relate with any mirror plane. Okay, so what is the definition for a diastereomer? Simply the non-superimposable non-mirror images or diastereomers. So here the first statement is given as 1 and 2 or non-mirror image stereoisomers. It is correct. Okay, because they are diastereomers. What is the definition of enantiomers? Simply non-superimposable mirror images or enantiomers. So the first and two Sahar's projections are non-mirror image stereoisomers. So we can call them as diastereomers. Okay, so first statement is the correct statement. Okay, now just look at the second one here. So or the third one, so just give the same notation. So 1 2 3, so three here, so it is simply anti-clockwise, and that's why we are going to give our notation for it. Now 1 2 and 3, so it is clockwise rotation, and it is yes. You can see one here, you can see on the first carbon we have 1 R, and on the second carbon it is 2 yes. Okay, so as we said, for the first Sahar's projection, which is having 1R and 2S, whereas the third one is also having 1R and 2S. That means these two are simply identical. Okay, so 1 and 3 are identical. So second statement is also the correct statement. Right, now just look at the third one. That just look at the Newman projections, and which are converted into wedge forms. Now how to give RS notations for them? Now just we are looking the molecule from here. Okay, so the first priority for this hydroxy group, second priority for this branch, and third priority for methyl group, and fourth priority for hydrogen. So the priority direction is anti-clockwise direction with the least priority hydrogen on the thick line. So we need to take the opposite notation for it. So it should be R. Okay, now just look at the same way. From here we are looking the molecule. So first priority for chlorine, second priority for hydroxy group, and third priority for this branch, and fourth priority for hydrogen, which is on the thin line. Now the priority direction is anti-clockwise direction with least priority hydrogen on the thin line. So we need to follow the priority order to give or to assign RS notation. So here it is yes. Okay, it is yes. Now so just try to check on the first Sahar's projection. We have 1R and 2S. Now just look at here the first carbon, just label the carbons here as we do. Okay, so for one for this carbon which is connected with the chlorine. So second carbon here, on the first carbon we have 1S, and on the second carbon we have 2R. Okay, so you can see RS and SR relationship, which is simply giving enantiomeric relationship. So we can say that 1 and 4 are enantiomers. Okay, now just try to look at the last one, last Newman projection. Now try to give the first priority for hydroxy group, and then second priority for this branch, and third priority for methyl group, and it is anti-clockwise direction with least priority hydrogen on the thick line. So we need to give R notation for it. Now just do the same thing here, 1 2 and 3. It is anti-clockwise direction with least priority hydrogen on the above the plane. Okay, or what we say on thick line. So it is R. So you can see the first one is RS, and the here what we say the fifth Newman projection is having R relationship. That's why 1 and 5 are diastereomers. They are in diastereomeric relationship but not identical. So from this analysis we can conclude that statement 1, statement 2 and statement 3 are the correct. So option A is the correct answer for this question. Okay, so here the conversions are very important. Just practice on converting from Fisher projection to Newman, Newman projection to wedge, and wedge to Newman what we say sawhorse and just do multi conversions. Okay, so if you have the strong command on them, you can solve any kind of questions on the by just relating by just notating RS nomenclature on the given conformations to find the relationship between them. Okay, so thank you very much, and if you have any doubts, you can just do the just do as comments and I will explain. And one more thing is, so please do subscribe if you didn't do till now. Okay, and if you're further interested, you can visit and join the website chemistry.online. Thank you very much.